All right, HVAC people, so you are in the right spot. Today, I'm gonna show you an easy method to help you troubleshoot faster and find problems quicker. This is what we call the pivot method in HVAC. Some people call it hopscotch, but that's old school. The new generation don't play hopscotch, they play basketball. So it's the pivot method. Keep one lead at a known reference, like a ground or a common, or just a known reference point. So this is the pivot method in HVAC troubleshooting. Just like basketball, where when you pick up your dribble and you can't dribble anymore to stop from traveling, you keep 1 foot planted and 1 foot you can move around. It's the pivot method right here to get your shot out. There we go, pivot method. So it's the same exact thing when we're doing troubleshooting. You're going to keep one lead grounded, which is your black lead, and you're going to have your red lead to try to find those where we missing voltages at. And I'm going to show you a real demonstration at an actual furnace. So stay tuned. We're going to do live in the field what we call the pivot method. Like I say, you're going to keep it at 1 foot grounded. We do it in basketball. So let's say, so we got one leg on common, and we're just going to follow those voltages until we find where we're losing the voltage at. So we might have a heat sequencer, and that'll be high voltage, but we're going to start off on low voltage on the furnace. And we're just going to use that pivot foot. Going to use that pivot foot to try to find your voltage. You have 24 here, 24 here, 24 here, and 0 there. We know that's our problem right there. So if I lose voltage right there, that's when I need to try to find out why am I losing voltage right here. So we'll have, or you can have 120, 120 at a sequencers, 120, 0. We know that's an open switch or something right there. So these are some components you will pivot across. You may have your thermostat, R and C, your W, your Y, your G. You may have a pressure switch or a vacuum switch, a rollout switch, a limit switch, a condensate safety switch, a door switch, a control board, contactor coil. That's that contactor coil. Transformer. So sometimes when we're troubleshooting, we have to troubleshoot while the equipment is powered. When you're chasing some of these faulty components down, whether it be a pressure switch, sometimes you have to do it while the unit is live. So I got my meter on voltage. You have to put your meter on voltage when checking it live. And you see these leads, like this, the pivot method. Remember, I had a black shoe, red shoe. This is my ground, my neutral, or wherever I want planted. This is going to be planted at all times. Good way to have this planted at all times. Want to get you a good alligator clamp to make it easier. The alligator clamp just screw down on this lead right here. This is going to be the one that's planted at all times. It's your pivot foot right here. This is going to be the pivot foot, and this is going to be the lead that we rotate. Like I say, this has to be in voltage. So we checking this live. If the unit was off, we can check continuity. That's with no power. Sometimes it's okay to check the unit. We have to turn the unit off to actually check the components. But at first, we want to use the pivot method to find it. Then we'll turn the unit off to troubleshoot the failed component further. But at first, we have to check in voltage. All right, so now we have our pivot foot, and we have our lead that we're going to chase the voltage with. To make sure you got good connection, should get a beep on continuity. All right. So our pivot, you see it says common on the control board. So we're going to put our pivot foot on that common right here. Another point, this could be like a ground right here. If you want to use a ground, there you go. You put that pivot foot on ground. But we're going to be using common, and we're going to go up to the furnace and check it live. I'm just showing you a demonstration right now, so stay tuned. We're going to go up in the furnace. But if I was just chasing voltages, this is what I'm moving around right here. This is what we're moving around. I'll lead. And remember, we can't move that. Let me screw this in good. All right, so I got that good and tight. Now remember, you get a penalty if you move this. See how that slipped off? This has to stay planted at all times. You cannot move your pivot foot at all. This just stays planted at all times. This is what we're going to be moving around. So we're just going to go to terminal, checking for voltage. All right. Like I say, so this is almost showing like the unit is not on. This method would do no good if you don't have power to the unit. It won't do nothing. Your meter won't change. It'll just be zero because you don't have power. But let's go to the unit. All right, so some of y'all are gonna get a shortcut. And when I say shortcut, ain't no such thing as shortcut, but an HVAC experience, because I wish somebody would have taught me this when I first started. In my first couple of years, I would just trace the wires all the way back, just trying to find, what was going on, or turning the unit on and off, because I didn't know this method, the pivot method, or the hopscotch method. And this right here, if I would have known this since day one, so if you're a newer HVAC technician, learn this method right here. It's going to save you a whole bunch of time and headache. Because I used to spend hours tracing down calls, especially when it's freezing in the attics and you're trying to troubleshoot a furnace. This right here is going to save you a lot of time. So I remember being in the attic 2 hours was something. If I'd known this method right here, I could have been find the source of the problem in like 2 minutes. So like I said, I wish somebody would have showed me this. All right, so before we pivot, I think it's very important also, just take a couple minutes to view the schematic and see what kind of components we have in the system. So all we're doing here, and I want to stay on topic, so I'm not going to go over schematic on this video right here. Leave in a comment if you want me to do a schematic video, but it's very important to just kind of just look over and see what kind of components you have. And you see it says component codes right here. So we just go down like flame sensor, fan relay, a fuse. We see a good ground that we can get. Gas valve relay, high pressure control, induced draft motor relay, limit control, low pressure control, main gas valve, thermistor. So it's good to just kind of get familiar with the components inside the system. All right, so as you can see now, the system is on, it's powered up. I got the pressure, the door switch bypassed, so I do have voltage to the unit. First, we want to get our meter somewhere where we'll be able to read it. And like I say, so the common point we're going to use is going to be, while pivot foot is going to be on this common right here. So we got us a good common. We'll put our meter on voltage. And this is the pivot method. The lead right here is where we're going to move around. If I put it on this red, I should get 24 volts. As you see, 24 volts. If I was calling for cool, this is my Y1 right here. You see I get 0 because it's not calling for cool. I'm looking for voltage. My system is in idle right now. So the only place I should get to 24 volts is the red. If I go to Y1 and I know my thermostat is calling for it, I should get 24 volts right here. If I get 0, we know we have to continue to troubleshoot. All right, so right now I got the system off. There's no power to the unit, but I just want to show you some of the components, how they look in here. Like I say, you need to get familiar of what's in your inside your unit. These are limit switches right here. This is what we check in the terminals. Like I say, we have to check this live. If we were checking this with no power to the unit, we can check continuity and see if this switch is open or closed. But with the pivot method, we can do it with the unit when it has power to it. That's what we're checking. And we got our pivot feet on the common, and we're just we'll put one. Go one right here. You should get voltage. You go to the top, you should get voltage. If we go here, we got 24, but we go up here, we got 0. Same thing on all of them. Pretty much just 2 terminals. On your press switch, same thing. Yeah. So we're just gonna go lead to lead. See the terminals? That's what we're trying to get to. All right, so apply the power, same thing with your gas valve. All right. A lot of time we forget about just the limit switch for the blower motor. If that blower not working, it's going to get real hot up in there because your heat exchange is kind of connected to the furnace, and this whole cage will get hot, and that limit switch will sense that. All right. So we have one pivot on common. As you can see, we got our meter set for voltage, and I'm gonna go to the thermostat and call it for heat. It's 70 degrees in the house. I'm going to put this up to about 75, right? Okay, before I do that, well, let's do this. I'm gonna turn it back off. Okay, I'm gonna turn it back off. So this is the pivot method right here. As you see on my meter, I'm going from common to red. Common to red. And I have 29 volts. You see, we call it for heat. See my W1 right here? W1. We have 0. Now I'm gonna hold my red. I still got my pivot on my common. I'm gonna hold this red on W1, and you're gonna see when I call for heat, we should start getting 24 volts. As soon as I call for heat, you see that change to 24 volts. That's a part of troubleshooting right there. If I call that thermostat and I call for heat, and I'm not getting 24 volts right here on my W1, if I was getting 0, we may have an issue with the thermostat because I'm not getting signal at my control board when it's called for heat. Okay? Remember all the limits? This is a limit switch right here. I'm trying to show my meter at the same time. All right, so my fan is on. See that limit switch for my fan? It should be closed because my fan is running. The limit switch is connected to this blower assembly right here. And it feels cool to touch to me, so it should be closed. Very important to know when your limits open and close also. But I'm put one lead. Remember, I got my pivot on common right there. So I got one lead on one side of that limit switch. You see I'm getting 24 volts. 24, 25, 26, 27. When I say 24 volts, that means at least 24 volts though, to complete that circuit. So now I'm pivoting to the other side of here. You see I'm getting 24 volts. So either one of these sides, if I was getting 0, I'm getting 24 right here. I go to the other side of that switch, I'm getting 24. All right. So let's go to the next one. Let's go back to this control board before we go over to the furnace section. So I got my pivot foot on common. Let's go to red. I should be getting 24 volts, right? I got 24 on red. Basically, that's just my transformer, sending 24 volts to the control board. That's another way to check your transformer. Let's go to Y1. That's my coolant, my compressor right there. I should be getting 0. This is another part of troubleshooting. If I was getting 24 volts on my copper heat and my compressor on the standard natural gas furnace, if I was getting 24 right here, that means we need to be troubleshooting. We could have a pitted contactor inside the thermostat, or I done seen it where the compressor and the heating turn on at the same time. We don't want that. So you see right now that H on my control board, I'm just calling for heat. So if I was getting 24 volts right here on Y1, if I, oh y'all my turn, you see Y1, I am getting 0, which we should. Let's go to the fan. Now, you can see my fan is on, right? My fan is on, but it's not calling for fan. This say if my thermostat, if I was calling for fan only, that's when I would be getting 24 volts. I should get 0 right now because it's on the heat. The heat is calling the fan to turn on after the delay. Let's go back over to my, still pivoted. Still got my pivot foot, I'm good. Not a violation. I go to W1 and I got 26 volts. So I'm just going surgical really with this right here. You see this, this my transformer right here. The transformer, yellow and red. Let's go to that terminal right there. You see that? On top of that terminal right there, I'm getting 24 volts. All right, that's what we want right there. If I was getting 0, we wouldn't be getting 24 volts to our board. All right. So let's go over to our heating side over here. All right, so it's the same concept. You see our limit switches for the heat? We got 2 over here. 1, 2. We should be getting 24 volts on all 4 points. So if I got 1, 2, 3, 4, you should be getting 24 volts at all those. If we're doing the pivot method, we lose 24 volts and get 0 or something. We found where we was losing voltage. All right. So you see, we got us a good pivot. We're gonna go to our 4 terminals right there. One at the bottom. 24 volts. Go to the next one. Pivoting. See that contact? Got our 24 volts. Gonna go to the next. Pivoting. 24, we'll go to the next one. pivoting. You do want to be careful with these leads and not touch the frame or anything like that. But remember I say, just get us a good pivot. And that's common. You see this neutral right here? I even think they make the terminals on that gas valve. That's a good ground right there. See if you see the terminal. See it? That's a good ground. And I think that's why they make it for it's like a little terminal. But that's a good pivot right there. And we're doing the same thing. Just go to your terminal. Got that good pivot. And back up a little bit so you see the meter too. Got us a good pivot right there on that ground. Like I say, we just touch the bottom of this limit switch. 26. What's the bottom of the next one? We got 26. You just chasing your limit. See that limit back there? We got us a good pivot on that gas valve. I'm just touching that limit point right there. See, I got 26 volts. Go to that top one right there. There we go. So now we're just going to that top limit right there. We got our 26 volts. Like I say, if any one of those switches don't get zero, we know we have to look into that. All right, folks. So before somebody taught me this method, I don't know what the camera cut off here, but before somebody taught me this method, I would actually have to turn the unit off each time. I would take the leads off, and then I would get my meter and put it on continuity to see if that switch was open or closed. Now, and this is how you troubleshoot these switches also. If you did have an open limit, or when you was pivoting and you find out on three of them you had 24 volts on, but on the top fourth one you had zero. But I would turn the unit off, and sometimes I had old helicopter homeowners hovering over me too, and it would take me 2 hours up there trying to find this. But as you see, that switch is closed right there. That means that switch is good. So this is what I would do. So I was like, man, that switch right there closed. So sometimes I would put everything back together and I would call for heat again. Because sometimes if the unit ain't running, that's what you have to do as far as just find the components. So I'll put that one back on. I'll call for heat again, let it do it again. I'm like, man, it started cutting off. So then I would go down. Because sometimes it takes 10 minutes before you go through a cycle. So I would take these back off, take the bottom two off, and I would check it for continuity. So I take this. Oh, it's hot. I don't want to burn myself and leave it on, but same thing. Okay, this is the gas valve, but if you were checking the gas valve, you would do the same thing. You'll try to get in there, get you a good terminal, and see if you're getting 24 volts. Let's see if we can do this. And sometimes you can get these leads right here. You can get them small as a needle thin. But like I said, if you read your schematic, another way you can do it, just say if I couldn't get to these right here, I'm gonna turn the unit back on. We're gonna call for heat. All right, so that's my inducer motor, and then my pin right here, we're doing the pivot. I got the black because we can't get to the conductors on the gas valve, so it's easier. You see, I got 24 volts on it. That igniter came on. We got 24 volts going to that gas valve. Soon as that igniter turn on. That's the pivot method for that one right there. That's the gas valve. All right. Now we want to check some high voltage things. So let me show you how to check the high voltage. So remember, when we're checking these components, you just want to really get you a good ground. I like to use a common ground, but when I'm checking high voltage, I prefer to just give me a good ground instead of the common or the neutral. I just give me a good ground right here. And you can check low voltage like this as well. If I go to the red right here, you see I'm getting 24 volts if I go to red. But see, I got a good ground. This is my inducer fan motor right here. So if I was using the pivot method, let's see if we got voltage to that inducer fan motor. They say sometimes it's hard to get a connection. So why easier is sometimes just go back to your control board. So let's go up to the control board and we're gonna see what kind of voltage we got at this inducer motor. Should be like 115, 120. All right, let's go over here. Inducer. I want to say this is the inducer right here. Let's check it. Yeah, you see we got 120. 120 on our meter. Let's go on the white one. And that's the common. Put your common to ground. So your black one, you got 120. So if you were troubleshooting this right here and your inducer motor not turning on, you was getting 0, you need to investigate that inducer motor. You need to find out if you don't have 120 going to it, if it's the control board or what's going on. If you got 120 and that inducer is not spinning, you may have a bad inducer motor. Let's see this door switch right here. Go to the black on that door switch and see what I'm getting. See my door switch? Getting 120. That just let me know my door switch is good. Like I say, when you're doing the pivot method, we trying to find out where we losing voltage. If I'm getting 0 coming out that door switch, that's when I know I got to kill my power. So if I was just troubleshooting that door switch or something, if I was getting 0, I would have to kill power and then come and troubleshoot this door switch by checking continuity. Well, that's another video. All right, HVAC people, so I'm gonna go ahead and end it right here, but I hope this was helpful. I hope I simplified the pivot method to help you be a better troubleshooting, faster, make you look like a professional in front of the homeowner or even your boss to save you time. Your boss will be like, wow, you got out of there pretty fast, but this method will come in handy. So learn it. Like I say, it's a lot more that we need to break down that I can show you. So if you want me to make a video on just breaking down components, we can look at the limit switch and see what limit switch is supposed to open when they're getting too much heat or excessive heat. Same thing with pressure switching. But even if you were outside of the condenser, troubleshoot the condenser on no cool, you can use this same method. Pivot on your ground and troubleshoot your contactor. Go from the bottom of the contactor. You're looking for 120. So you can use this method on high voltage also. You can use it when you troubleshoot electric heat, looking for high voltage. All right. And like I said, I can make a whole nother video on showing you that, but I have to get an electric furnace to show you that method right there. The electric furnace, a lot of times we're using 240 volts at that electric furnace. All right, HVAC people, like I say, I hope that was helpful. Leave in a comment what method you use to help you troubleshoot faster.